Good morning, geometry. Welcome back to distance learning. I appreciate your patience during this. I enjoyed your questions. The minimal interaction that we have, I feel is going to be good. Today we're going to continue talking about prisms and cylinders. We have, of course, prisms, pentagonal prisms, cylinder, triangular prism, rectangular prism, and so on and so forth. But today we're going to be talking about the volume of those. It's actually pretty easy. You have to find the area of the base. Now remember, the base is the two sides that are congruent and opposite each other, and it's times the height. The height is the distance between the two bases. Distance between the two bases. With the rectangular, it's kind of tricky which one is the base and which one is the height, but let's say that this side and this side are the bases, then this would be the height, the distance between the two. Here's the pentagonal prism. Distance between the height is right there. And of course, with your cylinder, circles are the bases, and the distance between them is, again, the height. It's the area of those bases and the height. So we have, remember, some of them are a little bit tricky. When it's a triangle, usually it's pretty easy, but remember that finding the area of that regular polygon can be a little bit tricky. Remember, it's that 1/2 of the apothem times perimeter, which was giving us all problems. But we can find it. So if we have this rectangular prism, not rectangular, pentagonal prism, gotta measure it. It is about 1.5 inches, or 3, we'll say roughly 3 centimeters. The side length is 3 centimeters. So we can find the rest of the stuff. And the height, we're going to say, is 6 centimeters. Okay. So what we have is, excuse me for a moment, is a pentagonal prism. There's a regular pentagon. And that's the best that we're going to do with it. We'll say that's 3 and that's 6. So what we can find is the volume of this. Remember, it's the area of the base, by the capital V, times the height. But remember, the base is 1/2 the apothem times the height. Well, we have to find the, not times the height, times the perimeter. My mistake. Perimeter. Well, perimeter is going to be easy. 1/2 of the apothem times 15. 3 centimeters per side, 1, 2, 3, 4, 5. 5 sides, but now we have to find the apothem. Remember, we do that by finding the central angle and finding this right here. So we know that if we split this up, we're going to put the 3 over here. We're going to say 1.5 and 1.5. So we can find that central angle. Remember, central angle is 360 divided by number of sides. 360 divided by 5, 72. This part right here is half of that. So that's 36. So now we can use trigonometry to find that side. We would use tangent because we have opposite and that's adjacent. So we would do tangent of 36 equals opposite over adjacent, 1.5 over adjacent. Adjacent, apothem in this time, they're both interchangeable. Remember, when we have one in the denominator, we need to find it. Really, all we have to do is switch them. So the apothem is going to equal 1.5 divided by tangent 3.6. So we do that using a calculator. 1.5 divided by tangent 3.36. Not 3.6, my mistake. Tangent 36. And that's going to be 2.06. So we go back over here. 1/2 times 2.06 times 15. Using our calculator, we come up with the volume of the area of this base as being 15.48. Multiply it by the height times 6 is going to be 92.91 cubic centimeters. So that's how we find that. So we have to do that for all of them. Remember that the central angle divided by 2 helps find that angle in the right triangle that we are needing. And remember that the central angle is 360 divided by the number of sides that we have. We're going to try this again with a hexagon in just a few moments. A couple of other things to discuss, not much. It's going to be pretty easy once you find that. Sometimes you will have these things that are not necessarily vertical. So if we have a circle here and it goes this way and a circle here, it's still a prism because they are parallel and congruent circles, except the height is now this distance. Same thing that goes with prisms. Height is the distance from one, the vertical distance from one to the other, is that direct distance. So let's say that this height in this case equals 4 and our radius is 2. It's really pi r squared, because that's the area of a circle, times the height. So in this case it's just pi times 2 squared times 4. So again, using the calculator, you would say 4 times 4, because that's 2 squared is 4, times 4 is the height, times pi. In this one right here, it would be 50.27 cubic units. And that's how that's done with these. So the last one I want to discuss is a hexagon. When you have a hexagonal prism, the let's say that the we're going to use a different sheet. Let's say that the side length of the hexagon is 18 and the height, the side length is 7.5 and the height of that is, that's the one, that's 18. With a hexagon, again, you know my drawing's not good. We're saying this is 7.5 and we need to find this area. Now we know, we've talked about this before, that this is 60. We know that what's left is 120, and therefore that makes these two congruent, and that's that 60 and that 60. So this is an equilateral triangle. There are many ways to find the area of an equilateral triangle. And once you do that, you can find the area of the hexagon by merely multiplying it by 6. We know that this is now a 30, 60, 90 when we split it up right here. 30, 60, 90. This is 3.75, 3.75. And we know that this height right here would be that times the square root of 3. So that gives us the apothem of 3.75 times square root of 3, which gives us 6. The apothem would be 6.5, and now we can find it pretty simply from there. So we can say 1/2 of 6.5 times 7.5 times 6 times 18. What these numbers are, right here we have our half, which is part of our formula. Remember, it's 1/2 area times perimeter, apothem times perimeter. 6.5, 7.5 is the side length times 6 is the number of sides. So this right here would give us our perimeter times 18 is our height of our prism. So let me actually draw a prism to show you that that's what that is. It's not going to be a very good one, but you all should be used to this. That's going to go out that way. That's better. There we go. It's not very good, but you should be used to it by now. So we have times 0.5 times 7.5 times 6 times 18 gives us about 2,630.55 cubic centimeters. I'm saying that these are in centimeters. It's long-winded, it takes a lot, but you'll have it, you know how to do it. One last little bit to discuss, and then be back, and I'll let y'all do your work at this point. Sometimes you'll have prisms that are multiple prisms. So sometimes you'll see something that looks like this. Rectangular prism on top of a triangular prism. You've seen angle addition, you've seen segment addition, you've seen all these other addition postulates, same type of thing. You find the volume of one, find the volume of the other. You can do that by kind of cutting them in half or along like an easy line to cut them. You find one, you find the other, you add them together. If you have any questions, comments, or concerns, please let me know. Good luck, and I'll post another video tomorrow.